All right, welcome to Math 0314 1.2 Applications of Linear Equations. All right, well, this section first starts off with a simple question, which is how can we describe each of these symbols? Okay, so I'd like to give you an example. The first one, I can call it adding or addition. So what I want you to do is pause the video right now and think of a couple of ways of saying each of what these symbols are. If we were in a classroom setting, I would have asked you to do 4. So pause the video right now, see if you can write 4 different ways of saying each of these. And I'm assuming that you've paused and you've given it a go, and let's see if I can think of some of the ways that you said it. So there's more than, sum, total. These are 4 different ways of writing. There's a lot more than these, but these are the first 4 that popped in my mind. For the second one, it's minus, subtraction, less than, decrease. These are the first 4 that popped in my head. This one right here, less than, is very, very important. When you see the word than, it's actually true here as well, you have to switch the order. So if I say 2 less than x, that actually means x minus 2. So just remember that when it says than, you have to switch the order. The truth is, if I say 2 more than x, I still have to technically switch the order, but x plus 2 and 2 plus x give you the same result, so we don't really stress over that one too much. Okay, all right, now here comes the tough one. This is multiplication, multiply, this is the one that most people think, times, and the nice one is product, and typically when you see the word of, it means to multiply. And the last one, that's definitely the hardest. This is divide. You can sometimes think the result is called a quotient. Part of. And don't get this part of confused with this, right? They're not the same thing. So let me be clear on that. If I say 2/3 of 15, that means 2/3 times 15, right? 2 is a part of 3, that would be like 2 over 3, which by the way gives you another one, over. Okay, so these are some. Your textbook lists some more, so I would give you recommend that you look through that, so you can see it. But what we're going to be playing with in this section is essentially translating math in words into math. So let's look at this next question here, and this is a good example of something that you could see. The sum of 2 numbers is 39. One number is 3 less than twice the other. What are the numbers? Okay. Now, I'm going to preface this by saying this section uses some more advanced math than we've necessarily covered thus far. I mean, this is only the second lesson. So if you feel overwhelmed, do your best. If you feel too overwhelmed, put this section off. Once we cover chapter 3, I feel like this section becomes a lot easier. So if you're struggling through this, and I'll be honest, some of these problems are actually very difficult and may be the hardest problems that you may deal with in the entire course, don't panic. Do your best. If it seems overwhelming, leave it alone. Once we finish chapter 3, let's come back to this. Okay? But let me see if I can, now that I've scared you, let's see if I can show you that this isn't too bad. Okay, so the sum, we said sum means you're adding 2 numbers. So in math, when you don't know what a number is, just make up a letter for it. We usually use x and y. So x plus y is means equal, so is 39. Next sentence. I'll do this in blue. One number is 3 less than twice the other number. So I don't know what the numbers are. I don't know which one's x, which one's y. But one number, we'll say x, is, I said is means equal, 3 less than, notice what did I say less than means? less than means you have to switch the order, right? So we're going to switch the order. We're going to say 3 less than twice the other. Twice is 2 times something less the other. What number is 3, less than twice the other? So x, one of the numbers, is equals 3 less than twice the other. That twice the other is 2y less minus 3. What are the numbers? So these are my two equations. And now to solve this, I'm going to use something called substitution. So, oops, I hit the wrong button. Let's see if I can do it. Yeah, cool. Okay, so let's tackle this via substitution. So if x equals something, then I can substitute that x value in here. So 2y minus 3 plus y equals 39. And we just go through and solve. So 2y and y gives me 3y minus 3 equals 39. And we'll solve this the traditional way. Add 3 to both sides. 3y equals 42. Divide through by 3. And y is, I believe that's 14. So if y is 14, I can take this value of y and I can plug it back in here. And now we have 2 times 14 minus 3, which gives me what? 28 minus 3, which is 25. I guess I should say x equals 25. Let me rewrite that. X equals 25. So y is 14, x is 25. Let's see if that makes sense. Is 25 plus 14 39? Is 25 plus 14 39? Yes. And here clearly we've shown that 2 times 14 minus 3 is 25. And there you have it. So this is just simply an exercise of translating word for word into math. All right, hopefully that wasn't too scary. Let's look at the next one. One number is 5 more than 3 times another number. The sum of the numbers is 45. Find the numbers. So my advice to you is to pause the video, try to do it on your own, and compare your results to mine. I'm going to assume that you've done that. And now let's tackle it. So one number, we'll call it x. So one number is means equal. 5 more than 3 times another. So we said than means you switch the order. So 3 times another, 3y. More is plus 5. If you put 5 plus 3y, because you remember me saying it doesn't really matter, if you say 3y plus 5 or 5 plus 3y, you will be fine. You'll get the same answer that I get. Next line. The sum of the numbers is 45. So we said sum means you add. So x plus y equals 45. And we're going to do the same thing. So if x is 3y, I can replace this x with 3y. And solve. So we'll combine like terms. 3y and y is 4y plus 5 is 45. Subtract 5 from both sides. I always like to use orange afterwards, and that doesn't show up well. Can't use that one either. Gray, I guess. Okay. Divide through by 4, then y is 10. Okay, so if y is 10, we go back here, substitute it back in, and so we have x plus, what did I say y was? 10 equals 45. Solve, subtract 10, x is 35. And so x is 35, y is 10, 35 plus, we can see that 35 plus 10 is 45, excuse me, and then 10 times 3 times 10 plus 5 is 35. So it makes sense. Those are my answers. Okay. Take a look at this one, pause the video and try to do it on your own. And I'm going to assume that you've done that. So let's see, how do I go about doing this? So 3 times the sum of 2 consecutive odd integers. So we have to think about what it means to be an integer first off. So recall integers are 1, 2, 3, 4, etc. The symbol that represents integers is usually the letter Z. This is the German word for numbers. It's where it comes from. And these are integers. Now let's think about what are odd integers. Odd integers are 1, 3, 5, 7, right? So if I say my first one is x, my first integer is x, what do I do to 1 to get to 3? I add 2. What do I do 3 to get to 5? I add another 2. Or I add a total of 4. So if the first integer is x, the second integer would be x plus 2. The next one would be x plus 4. And this is how we write consecutive odd integers. Also note that consecutive even would be the same thing, because if we were doing even, it would be, let's go to 0, 2, 4, 6. The gap between them is still 2. Between each of these is 2. So whether you're doing even or odd, it is actually always x, x plus 2, x plus 4, etc., etc. Now, we're doing the sum of 2, right? So the sum of 2 consecutive integers, let's do that down here. The sum of 2, the first one's x, the second one is x plus 2. What are we doing with them? We're going to sum them. And then it says what? 3 times the sum? So 3 times the sum, right? Notice it says 3 times the sum, not 3 times the first integer. Hence, that's why we put everything in parentheses, because it's 3 times all of it. And is, which means equal. I think that said 516. Let me double check. Yeah. Okay, so this one's actually easier to solve, right? Clean up the inside. X plus x is 2x plus 2. And we have 3 equals 516. Now, we could distribute the 3, but I'm always fishing for the easy way. And the easy way here is actually to divide by 3. Now, I do not know what 516 divided by 3 is, but I do know that 3 goes into 516. And the reason why I know that is it's the rule that the sum of the digits is divisible by 3, so is the number. In other words, 5 plus 1 is 6, 6 plus 6 is 12. Because 12 is divisible by 3, so is the number. So we know that this is true. And so we'll get 2x plus 2 equals whatever 516 divided by 3 is. So let me do that down here. So 516 divided by 3. 3 goes into 5 once. 21, 7, 21, 6 gives me 2. So it's 172. Now, since I'm in the process of doing fancy math, I'm going to do something fancy here as well. Okay. I'm looking at this problem here, and I'm seeing that all of these are divisible by 2, so I'm going to actually divide through by 2. You do not have to do this. You can subtract 2 and then divide by 2, but I'm going to do this just to show you a different way of approaching it. What's 172 divided by 2? That's not that as hard as it seems. 172 is 160 plus 12, and so if I divide each of these by 2, I get 80, and this is 6, put it together, it's 86. And if I subtract 1, x is 85. Okay, and there's my answer. Again, if you don't like that, and in hindsight it's actually probably easier, you could have subtracted 2 over here, gotten 170, and then divided by 2. 170 divided by 2 is 85 as well. But it's good to know different ways of approaching problems. So if 85 is correct, then what I'm arguing, let me write it over here, is that 85 plus 87, first two consecutive integers, right? Triple it. If I triple this, it should equal to 516. So what does this give me? This is 12 carry the 1, that's 172 times 3. And I erased it, but earlier here I had done 172 times 3. Right here is where I did it. Sorry. Divided by 3 gave me 172, so this has to be 516. So it is correct. So, there you have it. Hopefully that made sense, and let's jump on to the next one. 4 times the sum of 3 consecutive integers is 264. Find the integers. So, pause the video, give it a shot, and then we'll talk about it. So, I'm assuming that you've done that. Let's see what happens. So, 4 times the sum of 3 consecutive integers. Note here it says consecutive integers. So, this would be x plus 1, x plus 2. And the reason why we do that is if we're doing consecutive integers, we have here, what's the jump between each of these? Well, the jump clearly is 1. So, and we're doing what? 4 times this, right? So notice again it says 4 times the sum, so times 4 equals 264. Now, on this one, I'll go ahead and clean it up first inside. So we have 1, 2, 3 x's, so this is 3x. I have 1 plus 2, which is 3, so 3. And I have a 4 on the outside, and this is 264. Now, again, I'm going to piggyback off of what I did in the last one. I'm actually going to divide by 4. If you distributed, that's fine. 264 divided by 4 is actually very easy to do in your head. Just think of it as 264 is 200 plus 64, and divide each of these by 4. So 200 divided by 4 is really 20 divided by 4. 20 divided by 4 is 5. Just tack to 0, so it's 50. Oops. 64 divided by 4 is, now that might be a little difficult, but 64 is 8 times 8, if you're struggling. So it leaves me with 2 times 8, which is 16. So put that all together, you get 66. So 3x plus 3 equals 66. I could divide through by 3 again if I wanted to. I'm going to subtract 3. I think that it's probably going to be clear if I do it this way. And finish it off. Divide by 3. So x is 21. And let's see if that makes sense. If I take 21 plus 22 plus 23, add those together and multiply by 4, let's see what we get. So 1 plus 2 is 3, plus 3 is 6, 2, 4, 6, so 66 times 4, well, that's what I did here. 66 times 4 gives me 264. So this does give me 264. And I'm correct. So the integers are 21, 22, and 23. By the way, be careful on a test. It could say which of the following, what is the largest integer, what's the middle integer. And a lot of times people solve for x and they think that that's the answer, but it's saying what is the largest. So get in the habit of checking your answer, get in the habit of rereading the question. Also note that on these sort of problems, we've been saying consecutive integers is x plus 1, x plus 2, but you could also say x minus 1, x minus 2. That's legit as well, because if it's 1, 2, 3, 3 minus 1 gives me 2, 3 minus 2 gives me 1, etc., etc. So you can write it in a multitude of ways. Most of the time, this is sufficient. Okay, hopefully that makes sense. Let's go to the next section. So, the way the book illustrates this next part, this is called Applications Involving Percents and Rates. What the book does is it gives you these formulas. It says sales tax is cost of merchandise times tax rate, commission is dollars in sales times commission rate, and simple interest is principal times annual interest rate times in years. And we can use these formulas if you want to. I think that the better way of approaching is just to think about it and use common sense to figure out what the answer is. So let's see. I'll try to work it out both ways, but let's tackle some of these. So the next one says a woman invests $5,000 that earns 5.3% 5.25% interest. After 3 years, how much money does she earn? So let's see what's going on here. So she takes $5,000. She invests it at 5.25. So 5.25 is 5.25%. Earlier I stuttered because I just really wanted to write 5.25%. When I play with percents, I always like to write them out of 100. Okay? So I'm going to say 5,000 times 5.25 over 100. And if I multiply these two together, this gives me how much interest I've earned. Now, one thing we want to make sure we're clear with on the book, whenever it says interest in the book and it's not stated, otherwise, it means annual interest or annually interest. I guess annually doesn't make sense. Annual interest. Okay? So, if you just see the word interest, you can assume that it's annually. And so, if I'm doing this for 3 years, then what does that mean? Well, that means that this gets amplified by 3. And what this really is the last formula. Simple interest is principal times rate times the time. Gives me the simple interest. The way I learned this when I was in school to memorize this formula, I don't recommend you memorize it. But if you want to, if that's the way your mind works, it's IPERT. That's kind of the way that I memorized it. Principal, by the way, just means your initial amount, what you started with. Okay, and again, we can assume that it's an annual interest rate unless it states otherwise. Okay, so we would just solve that, and that would give me the answer. Now, I'm going to do something here on this. I'm going to just set up the problems. I'm not too concerned with what the answer is. You can work out the math, type things in the calculator. Let's jump on to the next one. Marcos earns $340 in 1 year. That pays a 4% dividend. How much money was originally invested? So here you want to be careful because what's happening is he made $340, right? So if he invests at a 4% rate, the question is asking, what was the initial amount, right? So to solve this, we would want to get rid of the 4 over 100. We want P, the original amount, by itself. So to do that, we always multiply by the reciprocal on both sides. Because 100 divided by 100 is 1, and 4 divided by 4 is 1. So the answer would be whatever 340 times 100 over 4 is, or 25 times 340. Okay, again, I'm not concerned with that. Let's go on to the next question. Amazon gives a 75% discount on the Kindle version of a book if you already own the audiobook. Find the original value of a Kindle book if you purchase the book for $10. Okay, so this question I think I wrote is a little confusing. But we're going to assume that the book was discounted. So if you bought it for $10, we're going to assume that it's been discounted 75%, right? So this is exactly like what we just did. So we have the principal times 75% of the value would give me the $10 that I purchased for it. So again, same exact thing. We're going to just simply multiply by the reciprocal to get P by itself. And whatever that gives me is going to be my answer. Okay, so I'm going to stop here. I got about 5 minutes left, and I got this one last section to run through. This next section is going to be a doozy of a section, so be prepared. These are going to be probably one of the hardest problems, if not the hardest problems we'll do with the entire semester. So be prepared. If you were struggling immensely with this next section, don't stress too much. We will come back to this later on. Like I said earlier, once we finish chapter 3, I think that this will be a little easier to tackle. So don't kill yourself in working on these. If you're struggling too much, just jump on to the next section. All right. So hopefully that scared you too much, and we'll tackle these problems next time. All right. See you guys next time.